This will be the first of 3 videos on simplifying, multiplying, and dividing rational expressions. So we're going to start with simplifying rational expressions. Make sure you get these key notes into your updated. Make sure you get everything you need here. So a rational expression is a fraction with a polynomial in the numerator and the denominator. We saw this with our inverse variation functions the other day when I had 1 over x or 10 over x. When I have an x in my denominator, some more complicated things start happening to my functions. The way we're going to simplify these functions is that we're going to factor and cancel common factors. I can only cancel factors. I can never cancel sums or differences. The other thing we need to pay attention to is that rational functions are undefined for x values that result in a denominator equal to 0. The basic rule that we're talking about there is we must not ever divide by 0. So let's look at a couple examples together here. Part A, this is one of our easier type of problems because we are starting in factored form. This is a product 16 times x to the 11th divided by 8x squared. All I need to do here is simplify where I can. I know that 16 divided by 8 is 2. I know that x to the 11th divided by x to the 2nd is going to be x to the 9th. The shortcut, remember, is if I were to take my exponents and subtract them, 11 minus 2 is 9. Now what I said earlier, we need to account for any values that make my denominator undefined. So included in our answer here, I must say that x must not equal 0. Because if it did, my denominator would equal 0 and my whole function is undefined. So that's when things are good, that's when things are nice and easy. Let's move over to part B and see how things can get a little bit more complicated. Hopefully as you look at this problem, this looks a little bit familiar. I have a quadratic trinomial that I can factor. If I look at my numerator, I can factor this into 2 binomials. I can factor this by finding a pair of numbers that multiply to -3 and add to -2. In this case, that will be x minus 3 times x plus 1. We're going to do the same thing in our denominator, and we're looking for 2 numbers that multiply to 4 and add to 5. In this case, that will be x plus 4 times x plus 1. Hopefully you see what I see, and then I have a common factor here that we can cancel. So for this problem, my final answer will be x minus 3 divided by x plus 4. But remember, I need to account for any values that would make my entire denominator 0. So I must state that x cannot equal -4, and it cannot equal -1. Even though we canceled this factor here, if x were to equal -1, the entire denominator would become 0 at the beginning of the problem. So I need to include both restrictions on my domain. Let's look at a couple more together. If I look at part C here, I can't do much with my numerator. It's 3x plus 4. That is as simplified as it will go. So I'm going to rewrite 3x plus 4. My denominator I need to factor, and I'm looking for a combination of factors that multiply to this trinomial. I can do the British factoring method if I'd like, get 3x squared plus 4x minus 3x minus 4. Factor by grouping, x squared comes out, 3x plus 4 stays in. Over here, -1. Sorry, this is not squared, it's just regular old x. -1 comes out, and 3x plus 4 stays in. So when I factor this, I get 3x plus 4 times x plus 1. Hopefully you see it. I have a 3x plus 4 in the numerator and denominator. So when I write my final answer here, it's going to be 1 over x plus 1. Just pay attention here. I canceled out my numerator by dividing by the same number. So my numerator becomes 1, not 0. Our final step here is we need to state that x must not equal negative 1, and x must not equal negative 4/3. That comes from this factor here. Let's look at just one more problem together, just so we see all that can happen. Over here on part D, I'm going to factor and try to cancel best I can. I think the denominator is easier to cancel. It's going to turn into x minus 2 times x plus 1. Our numerator, I want something to cancel. And if I were to factor out a x from my numerator, I would have x times 2 minus x. Now I want it to match up with that x minus 2. So instead of factoring just a regular old x, if I factor a negative x out, my signs will flip. So I'm going to factor this. I'm going to write this as negative x times x minus 2. Now I can get my red pen out, cancel my x minus 2's, rewrite my final answer as negative x over x plus 1. X must not equal negative 1 or 2. I'll leave the U tries to you. You should work on those now.